All right, welcome. Today we're talking interior parts of a triangle, some pieces that we'll be using vertex and midpoints. The first one I like to bring up and go over is your altitude. And I like to actually look at it. We'll look at it first. So altitude is a line used in a triangle to determine height or elevation. Now, in order to do that, you would use or connect your vertex perpendicular to your opposite side. So if you were asked how, in words, to create an altitude, you would say, I would draw a line from the vertex perpendicular to the opposite side. And what that does is creates the shortest distance from your vertex to your opposite side here. And we call this an altitude. And when I put this parentheses, I'm talking about what it's connecting. Vertex, which is perpendicular to opposite side. So just some things you can use to remind yourself when you look at it. Now, each triangle has 3 vertexes and 3 sides. Therefore, there are 3 altitudes. And what you see with altitudes frequently is this is used for height of a triangle, especially when you're dealing with area. And since area is 1/2 base times height, this height in your triangle, area of a triangle formula, is generally your altitude. And this is the idea, basically, if I had a plane up here and I want to see its altitude, maybe from takeoff to landing, I want to see its altitude where it is. This is what I'm using here. Now, there are a couple special cases where if you had a right triangle, your altitude is actually your leg of that right triangle, because it is connecting vertex perpendicular to opposite sides. So this here is your alt, or your altitude, your alti. And then you also have the triangle where you have an obtuse triangle, and it's hard to draw a perpendicular line from this vertex here. So what needs to be done is you need to actually extend a line to the exterior of the triangle. So maybe in this case, this is not so much an interior part as it is just a way for finding height of this triangle. And this here would be your altitude of this triangle. And again, we're looking at the vertex and the opposite side, and that's the 2 key pieces of your altitude. Let's look at what's called a midsegment. Now, a lot of times you can just use the word to kind of help you. All right, mid, so let's think midpoint. And segments, we could think, your sides of your triangle, because that's what makes up a triangle, is 3 segments. So if we were to look at a triangle, I would have 3 midsegments, but let's just look at one by taking a midpoint. And I know this to be a midpoint because I have my 2 slashes here, which means that point is equidistant, and then I'll connect it to another midpoint here. And in doing so, I've created a midsegment here. This is my midsegment. And you have 3 of those, because you have this one here to this midsegment, and you have this one here, and that's also could be known as a midsegment, because you basically, if you have 3 midpoints, you're going to have 3 midsegments. Now, a couple of things you want to look at. Well, first of all, what does that connect? That connects a midpoint to a midpoint. And some of the things you should know about a midsegment, a couple things it does is, one, it splits your side of your triangle into two equal pieces. So if I gave you, let's say I gave you this as 12, you could tell me this whole side here is 24, because if this is 12, then this side here also needs to be 12. And another thing you could tell from it is that this midsegment will always be half of your base. So if this is 15, if this midsegment is 15, then that means this base is going to be 30. It'll be double. So if I'm given a midsegment and this says is 14, I'll take half and get 7. If I'm given the midsegment 3, I'll know here the base is 6. It's a 2-to-1 or 1-to-2 relationship, and this is my midsegment here. Again, you're just looking at midpoint and midpoint. Probably want to spell that right. Another part to look at, and we'll look at both here, is your perpendicular bisector and your angle bisector. This is probably the easiest one to remember because it is what it is. Well, a lot like the other ones. It is what it says it is. So how do I bisect a side? Well, I use a midpoint. And then if I want it to be perpendicular, I need to intersect it at a right angle. So all this needs to have is a perpendicular line and a midpoint. That's a perpendicular bisector here. No vertex, there isn't any vertex that's needed in most cases. You may have a perpendicular bisect that has a vertex, but it doesn't need to have the vertex. And then with an angle bisector, and again, you have 3 of those. Like I have a perpendicular bisector here. I have a perpendicular bisector here. And then an angle bisector will take any angle. All you're really looking to determine here is that you're just taking any angle in this triangle, and you're using this line to cut your angle into 2 equal pieces. And that's why I have the x and the x to show that, x is equal to x. It's the same. And sometimes what you'll see is they'll give an arc with a single slash just to show that those this is an angle bisect. Those angles are congruent, or they're the same measure. And again, I could draw, let's call this y and y, that's an angle bisector, and let's call this z and z, that's also an angle bisector. All it does is bisect 2 equal pieces, bisect angle. Again, no vertex. Well, actually, yeah, vertex would be included in that because it starts at the angle vertex. And then, last but not least, you have your median, which I like. It's a good line. It's a good piece. Where you have a line connected from vertex. Now, altitude is vertex perpendicular to the opposite side. Be careful, median is vertex to midpoint. Vertex to midpoint. Vertex, let's do another color here. Vertex, that was a bad line. To midpoint. That's a median. Vertex to midpoint. Connects vertex, say again, to midpoint. I'm saying multiple times because sometimes students, tend to get this mixed up with other pieces. And this here is known as a orthocenter. It's where three medians connect. And there's also a ratio here of 2x to x, meaning if this side is 10, then this side would be 5. If this was 15, I'm sorry, if this was 50, this would be like 7.5. So there's another 2-to-1 ratio of, and let me just make sure you could see that, of like this is the 2x, and this here is your x. That's the ratio of 2x to x when you're dealing with medians. Now you do have this super triangle, let's call it, your equilateral triangle. Oh. Let's say this is equilateral. Let's say all sides are equal here. And I draw a line from the vertex perpendicular to the other side, but this point here ends up being a midpoint. And this line actually ends up being an altitude because it's vertex perpendicular. It's a perpendicular bisector because it's perpendicular and it has a midpoint. It's also a median because it's vertex to midpoint, right? Vertex to midpoint. And we could also say it's an angle bisector because if this were an equilateral triangle, both of these would be 30 degrees. So there is a case where you could have more than one, something represent more than one piece, two angles, let's just say congruent there. This maybe call this your super line. I would know this. This would be a great bonus question. Draw a super line, demonstrate why it's super. That's it, because it's 4 separate things. And those are your parts of triangles there. There's about 4 to 5 different parts, and there's a lot of little hidden pieces to it. So this should help you with diagramming and deciding what parts are being given to you.